Hello, welcome to George Mason's webinar. We're going to wait a few minutes to allow people to enter and register. So please bear with us for a minute or two while we allow participants to come into the webinar. Thank you. Is my sound coming through okay, Jennifer? All right, thanks. All right, we're going to go ahead and begin. Welcome, everybody. Good morning. Welcome to George Mason University's Center for Real Estate Entrepreneurship and our webinar today called Factory-Built, Modular, and Prefabricated Building Strategies in Projects in the Washington, D.C. metropolitan area. My name is Eric Maribojek. I am the Director for the Center for Real Estate Entrepreneurship at the George Mason University School of Business. For those that don't know us, the Center for Real Estate Entrepreneurship is George Mason University's platform for real estate education and research. We run a couple of programs. We have a master's program in real estate development. We're about to launch an undergraduate minor in real estate at the School of Business. We have educational programs and executive education for both academic and industry audiences. All of this would not be possible without the support of our center's advisory board. Our advisory board provides financial support, leadership, and guidance that allow us to present programs like the one we have today. Building real estate projects with factory-built, prefabricated, and modular components have long promised to deliver buildings faster, more efficiently, and more sustainably with less construction waste and building errors. Our market conditions and technology advances finally ripe for more widespread use of these strategies. We are very fortunate to be joined today by a panel of real estate experts and companies at the forefront of prefabricated and modular design, development, and construction in the Washington, D.C. area. So I'd like to introduce our four presenters for today. Jennifer Max is a senior project executive with Gilbane Building Company. Jennifer has over 25 years of experience in the industry, focusing on all aspects of project delivery from pre-construction to completion. Her project today will be a presentation of citizenM, the first modular hotel development in Washington, D.C. Megan Mitchell is an architect with Eric Colbert and Associates since 2017, with a career dedicated to housing design. Since 1998, she has played a primary role in the design of projects ranging from single-family houses, townhouse flats, and pocket communities, and larger apartment buildings. Dave Yampolsky is a senior vice president with DC-based Community 3 Development and has worked in the Washington, D.C. real estate market since 2004. Having led various asset management, property management, development, and general contracting teams, his project experience represents a wide range of assets from boutique multifamily renovations to larger mixed-use developments. Megan and Dave are here today to share a project called Petworth Share, a modular apartment project in Washington, D.C. And finally, we have Gene Frogel. He is the president of Annandale Millwork and Allied Systems Corporation. which supplies structural building components and high-end architectural millwork to home and multifamily builders. He is a senior life director and current president of the Northern Virginia Building Industries Association and is also a proud alumni of George Mason University. He is here today to talk about the growing percentage of single-family building components that are now factory built, including in his factory complex in Winchester, Virginia. So just a reminder to all the event participants that just joined us, if you have any questions, please feel free to use the chat feature, and I will pose questions to the panel at our various breaks and the last 10 or 15 minutes of this session this morning. Also, this program is being recorded, and the link to the recording will be sent to those who registered for this event. So without further ado, let's start our presentation today, and I'll turn over the screen to Jennifer.
Good morning, everyone. Hopefully you can hear me, Eric?
Yeah.
Great.
That's good.
Wonderful. So excited to present to you this morning to talk about the modular hotel that's currently under construction for the citizenM brand, which will be the first modular, volumetric modular hotel in DC. So a little bit about the hotel. It's 104,000 square feet, 296 keys, and located in the NoMa area of DC. Wanted to show you some pictures. This is not your typical hotel. This is a boutique micro hotel. So the rooms are a bit smaller, actually quite a bit smaller than maybe some of the other rooms you've been accustomed to. Because of that, it lends itself very well to the sizing of a modular assembly, and much of the room is built in the factory. So here's some pictures from one of the factories that I visited during our analysis period in China, where you can see that the beds, the vanities, basically all the millwork, glass, even the curtains and lighting are installed within the room. So this is what it looks like in the factory, and then this is what it looks like in the finished room. So really all the bed is missing is basically the sheets and the little accessories that make it feel more homey. So wanted to at least start our conversation to talk about when we say modular, that means a lot of different things. So, you know, obviously there's lots of discussions about modular, and so it's important to understand like which aspect of it is part of the conversation. So first, I've split this up into prefabricated and modular. So when we talk about prefabricated, we're talking about individual pieces of the building being fabricated off-site and then delivered to the job site for assembly. So in some cases, that can be stuff like single trade. So like when metal studs are assembled as a truss assembly and then hoisted onto the project site for installation. Or it can be things like multi-trade, where we have corridor rack assemblies that contain multiple trades that are the piping. This is very common in healthcare construction, for example, because of the amount of piping that's in the corridors. When we move our conversation to modular, we then need to split it up into a couple different categories. So first is the category of relocatable. So, you know, this, you'll probably picture this more as like trailers where, for example, when schools are looking to have surge capacity, this particular project is a project we did that was a healthcare job that was looking for a little bit of excess capacity and wanted the ability to then move that module to other projects after the need had passed. And then when we look at permanent, again, a couple different breakdowns. The first, panelized. The best example of this is the new trend for panelizing exterior wall assemblies, where you have the studs, sheathing, vapor barrier, the finished product, whether it's GFRC or EFIS or any kind of stone material that is built in large enough sections that it's hoisted onto the building so that you're not individually moving the trades through the project. And then this last category, which is my example for my project, which is the volumetric, where the actual structure of the building as well as the fit out is all prefabricated offsite and delivered to the project. So wanted to specifically talk about volumetric modular. You're going to see some examples of pictures, both from a factory that I visited in China, as well as the factory for the company that we're using for our project, which is Polcom, located in Poland. So the important thing about this is that there's actually two very distinct parts of the fabrication process. The first is that the structural cages need to be fabricated for the individual rooms. There's a couple different techniques that are used for this. So whether it's actual structural cages, or you'll have also seen examples of shipping containers that are used to create that volumetric structure of the building. That is typically located at a different factory location than where the actual fit out of the assemblies is done. It's just a very different type of process for assembling the structural components. And then when we move into the factory itself, so in our case, we are doing full fit out within the factory. So that means all the MEP work is roughed in, all the drywall, painting, finishes, millwork assemblies, all of those are installed in the factory before the units are shipped. There's some unique things that are done in the factory to allow us to later connect all these items together on the job site. So you'll see on the right-hand side some examples of some pictures where the piping essentially sticks out of the wall, which then allows us to connect these items together on site. There's also in our units some creative access panels that are created. So in the rightmost picture, you'll see that's actually a millwork panel that's providing access to some of the electrical components for the unit. So that allows us work once it arrives in the US for installation, as well as maintenance access later on by the end users. Once the units are fabricated and fully inspected, they are wrapped, ready for shipment. So they're put on boats and headed over to the US. And so there's a lot of very specific detailing that's involved in making sure that these units are watertight and that there's no breaches of the water assembly as they do their slow boat over from either Europe or from China in order to get to the US port. In our case, the place that the factory is located is in Chojnica, Poland, which is in northern Poland, so directly adjacent to a waterway. And we'll be taking delivery of the units at the Port of Baltimore. We've actually chosen to use a private port development in order to accept it, as opposed to going through the larger port authority. And you'll see the reason why in just a second here. So what happens at the project site, so we're currently under construction at the site. We've completed the excavation for the hole, put in the deep foundations, and are working our way up to get ready for concrete. We essentially pour our concrete up to a transfer slab. So in our case, that's at the second level of the building. So everything below second level is traditional construction. So things like the lobby spaces, the dining, the bar area, all of those will be constructed within the US using traditional methods. And then once we get to that second floor transfer slab, in addition to that, we're also pouring shear walls that are the elevator cores that will go up the entire length of the entire height of the building. And then the modules will get stacked on top of those on top of the transfer slab, and then basically on top of each other, kind of like a big giant erector set, and then will be tied off to the shear walls to create the structural support for the building. Once all the modulars have been installed, we then have another series of slabs that we'll pour. So one of them is like a topping slab, then we'll have a mezzanine level, and then complete the roofing area on top of the building. So this is a picture of our project site. I think this was from a few weeks ago. It's been very muddy lately with all the rain we've had. So we've been struggling a little bit to keep the mud under control. But you'll see this is where we started to build our tower crane in the middle of the site. And so this parking area is actually not technically part of the footprint. We lease that from an adjacent developer. And that's where we'll be staging the units when they arrive from the logistics company. So we have room to basically store around 5 units on site. So this is very much a just-in-time delivery system. So we have to work closely. We hired a third-party logistics company who will accept the units at port and coordinate the trucking of the individual modules to the project site. An individual module, for the most part, is 2 rooms with a corridor in between. So if you picture the two rooms on either end are completed and the corridor is not. So once all the units are stacked and everything has been certified, we then go back in and finish all the corridor spaces, finishing like drywall and finishes and everything else but for the most part, the rooms are complete, including actually the door on the rooms is hung and closed. So we provide very limited access to trades at that point. Really all that has to be completed in the rooms once they arrive in the US, fire alarm and fire sprinklers, because of the code requirements that those need to be installed by certified installers from the US. We only have raceways installed in the factory, and all of the completing work is done by a certified contractor in the US. There's one other like snicky wicket. There's a little pendant light that hangs over the bed in each of the rooms that wouldn't transport very well. So those we actually buy stateside and will install once they get to site. Other than that, we're really just going into the rooms and putting in some microwaves and sticking a little under counter fridge. Like the rooms even come with the safe installed underneath the bed assembly that's been provided. So for us, it's really nice that the rooms are fully completed and then we're able to finish the construction. One of the challenges though, because of what the construction is, we're essentially building the project backwards. So I had mentioned that we stack all the units on site and then finish off a topping slab with a mezzanine. That means all of our major mechanical and electrical equipment is located on the roof of this building. So all these finished rooms and spaces are going to show up to the site, and then until we can actually install and activate all the mechanical and electrical equipment, we have no services in the building. So it brings in some logistical challenges with how do you protect things like finished millwork and finished paint and wall covering materials when you have no conditioned air available. So we definitely needed to think about temporary provisions to keep all those materials appropriate. When we were looking at our project, there are a lot of different vendors that have started working in the volumetric modular space. I wanted to include a couple names here that you may have seen if you've been following this space. So for us, when we were looking at our project, we had looked at Deluxe and Z Modular. They tend to play in the US in more of the low or mid-rise space, so more like 4 to 5 story hotel type products. So it wasn't as relevant to our project since we were taller than that. We then did a formal RFP process where we looked at 3 vendors, Full Stack, who is located in the US in the New York area. And then we looked abroad at both CMIC, who is a Chinese fabricator, and then Polcom, who we ultimately selected, who is located in Poland. I'll talk a little bit about some of the challenges and opportunities that come with working internationally. This client is an international hotel client and has worked with Polcom and CIMC before. So both of those vendors were familiar with their details and finishing. And so that's the reason why we leaned more towards the international fabrication as opposed to the stateside. So unique opportunities with volumetric modular, but certainly some significant challenges that the team needed to be aware of as we've been working through the project. So first is chain of custody. So it's taken me a really long time to get my head wrapped around how complex the handoffs are regarding modular. So this graph I think looks awesome, but it's like a year of me thinking through exactly how do we make sure that at each time that module essentially like changes hands, that we've appropriately addressed the risk and the sign-offs that are associated with that particular company. So starting with step 1, we have the fabricator is making the structure, and then essentially they have their own handoff process to themselves to do the fit out. So those are the pictures I was showing you between the 2 different factories. So there is an internal handoff that they manage to make sure that the cages have been fabricated correctly, meet all the appropriate tolerances and fit out requirements before they're actually started to be fitted out for all the interior materials. At that point, the units, and during the factory interior installment, we have people in the factory. This is a remote job site to us. So this work is being performed as, you know, if it was being performed within the US, we would still have an obligation to perform inspections and make sure that the work is being appropriately installed according to the documents and code requirements. So we have inspectors in the factory, as well as the owner has hired a third-party international ICC certified code inspector who performs all the inspections that need to be done before walls get closed, as if it was a regular job site within the US. So all of those inspections are managed within each of the individual modules. And then once the unit is fully done, there's another inspection to make sure it's basically seaworthy and ready for shipment. At that point, it's loaded on the boat by the company and shipped over. They still own custody of that unit until it has passed through the duties process within the Port of Baltimore. And then at that point, we have a joint inspection that will happen in the Port of Baltimore that will have both inspectors from Gilbane as well as Polcom to verify that the units have actually come over the sea undamaged. You know, there hasn't been anything that's fallen off the wall. There hasn't been any water infiltration. Like, you know, that the rooms basically look exactly the same as when they were loaded on the boat in Poland. And then at that point, we have a third party that gets added to the process, a third party logistics company. So they're the ones that are actually unloading the units at port and storing them for us until we're ready to receive them at the job site. So they're also part of the inspection, because we essentially, Gilbane is accepting units from Polcom, and then we are transferring responsibility of those units over to our third-party logistics company. At that point, the third-party logistics company is responsible for those units until they're physically delivered at the job site. Once they arrive at the job site, we then need to do another inspection where we basically relieve the third-party logistics company of their responsibility, and then we hand responsibility to the company that's going to be erecting the units. Once they're erected, we do another inspection that basically alleviates the erection company from having caused any damage during the installation process. And then we go on our way and finish out the rest of the room. It's really important to have all those different inspections, because if anywhere along the way some damage has occurred, we want to make sure we understand what party caused that damage. And there's also significant handoffs as it relates to the different insurance products that we have. So whether it's the insurance for marine transport or the insurance for cargo moving through auto liability, there's this very complex process of making sure we're actually at all times under some type of insurance to cover any damage that might occur. So our inspections, we're using our project management software, Procore, to accomplish that. And we're also using a photo documentation software called Hollow Builder, which allows us to take basically time-lapse photos of every wall at every step in the process so that we've got the photos to supplement our checklist. So opportunities, I mean, the biggest thing with this process is the speed to market. So while we're working on foundations and trying to come out of the ground, the factory in Poland opened about a month ago, and we're about, I think they have a third of the cages currently sitting on the factory floor in some various stages of fit out. Quality control is much better, you know, from an assembly line process that we now have this very regimented way that we're walking through each unit. If you think about when units are spread among 11 different stories and how many units per floor, and now from an inspection standpoint, somebody can literally just walk like a factory floor room to room and perform their inspections. So it does allow for much more of that manufacturing mindset for ensuring that things are being installed correctly. For the most part, there's no on-site punch list. Some of the punch list is happening through all those different chains of custody, but the very robust punch list process is happening before these units are put on the boat for transport to the United States. From a waste reduction, sustainability standpoint, you know, all the things we talk about in terms of like right sizing materials and, you know, not having these volumes of dumpsters that are collecting waste that occur on a traditional job site, we don't see that. So that's definitely a benefit to this type of project delivery. And then safety, you're not dealing with like as much of the transport through the building and, you know, needing to hoist materials through windows or through buck hoists, things like that. So it can result in a safer work environment. The challenge is the list is longer, and there's a reason the list is longer. This is definitely not for the faint of heart. It is very technically challenging. And so the amount of technical knowledge that the architect needs to have, as well as the construction team to actually make sure that this project goes well, working with the fabricator, I'd probably spend more time, and my team spends more time on technical coordination than we would on a traditional construction build. We have 2 job site locations we need to support now. So it's not like it's this remote site and I wait until stuff comes up. I actually need to put people in the factory to actively inspect and monitor the work. As I mentioned, the owner needed to hire a third-party agency. So getting approval of the local jurisdiction to actually allow for this work to happen was not bad in DC. They were very comfortable with this. They'd had other projects where it's been pursued. I was looking at this for another market with this client, and it was a complete non-starter. It was going to add a year to the schedule just to make the agency comfortable with the idea of modular, which obviously kills the whole idea of speed to market. COVID for all of us has been a crazy world. Trying to support a factory in Poland has been, I couldn't even get my head wrapped around like, well, how we were going to actually do this, because we needed to put people in Poland. And the problem was I can't get people to Poland. I don't even know if the borders will ever open up this year. So working with the company, we were able to identify some individuals that were already in Europe that had experience with modular that are working on our behalf. So we are on FaceTime. Our QC inspectors in the US are on FaceTime with them almost all day, every day, helping to inspect things, because we have a lot of significant contractual risk in making sure that things are being built correctly and being inspected. And I'm less comfortable with that idea that I couldn't actually put members of my team there to perform those inspections. The safety, now we're hoisting and installing these huge modulars on site. So the trade-offs of the individual worker versus the risk of the actual modular, there's still safety concerns that need to be addressed. And certainly the logistics on site are extremely challenging, especially when you're in a DC footprint and you don't have a lot of room to move. So coordinating all these just-in-time deliveries and making sure, you know, these are oversized loads, so they can't be on the road except for certain times of the day. And so you want this process to go as seamless as possible. So making sure that we've thought through all that stuff has consumed a lot of brain time. And then the tariffs and taxes changes was actually an interesting thing. So especially when you're working with international companies, like as the laws change. So for example, we were originally supposed to use the Chinese fabricator. And then there was a significant tariff change that had come out from the White House that basically killed the deal. And we needed to pivot and go in another direction. So you just need to be aware that there's risks with being involved with the international market. So, you know, the biggest thing, this isn't saving money. Like there's no way that we can do a comparison to say that because we're making these in Poland that it's costing less expensive, but it certainly is a net value to the owner, because this product, we're actually going to be done 5 months earlier than we would have if we had built it using a traditional on-site construction. So obviously, you know, the math of 296 hotel rooms online for 5 months extra is a huge net to the owner's bottom line. So I thought this quote is very appropriate. It seems like the target's always moving. There's different things that we're focused on. So it takes a lot of brain power to really think through this. We're excited to figure out how this all comes together. And our hotel will be finished in September of 21. So we've got a little work to go, but we're looking forward to it.
All right, thank you, Jennifer. That was a great presentation, and we certainly look forward to seeing the hotel go up. I think that will be an interesting thing to see, as well as hopefully touring the hotel next year, and the hotels have kind of recovered from what we're going through right now. What we're going to do now is I'm going to go ahead and ask the next presenter, Megan and Dave, to start sharing their screen, and I will get to the questions after all the presenters have finished their presentations. So from DC's first modular hotel development, I now turn you over to Megan and Dave for DC's first wood frame modular apartment development.
Hi, good morning, everyone. Thanks for having us, Eric. And thanks, Jennifer. That was a great presentation. Interesting comparison to this project, which is much smaller and is wood construction. So Eric, you referred to the project as Petworth Share, and that's been our sort of pet, no pun intended, name for the project. But the building has now been named Modo. So here you have the rendering of the building. It's also under construction at the moment. It is 4 stories of wood modular construction over a steel podium structure. This project is located in the Petworth neighborhood of DC. It's kind of on the edge of a row house neighborhood and right at the hub of the Georgia Avenue Petworth metro station and the major north-south avenue, Georgia Avenue and New Hampshire Ave, where there are lots of buses and bikes and people, and quite a vibrant and interesting neighborhood. Here is the land use map for that neighborhood. Again, we're on this sort of edge of the commercial corridor, so we're kind of straddling between the taller buildings along Georgia Avenue and then these lower 2- and 3-story row houses. This is the site before we started construction. You can see the metro close by. The zoning for this area is the Georgia Avenue neighborhood mixed use NC8 zone. And that permits mixed use development and medium density with a focus on employment, including additional residential uses above improved commercial uses. And that's exactly what we're doing. We have a ground floor retail with the 4 stories of residential above. This is on the Rock Creek Church side of the site. So you can see the taller apartment buildings along Georgia Avenue. And then our site will kind of mediate between those lower townhouse buildings and then the taller buildings along Georgia Ave. And then here's the site from kind of standing near the metro and looking across New Hampshire Ave right here. You can see the row houses beyond. And I think that this building being a little bit taller in this location will be helpful in kind of blocking some of the noise and buffering a little bit of the commotion at this intersection, because it's quite a busy intersection in the city. So here's the ground floor of the site. It's a relatively small site, only about 4,800 square feet. We did get a BZA exception for parking, so we do not have parking. And the site is located not directly above Metro, but obviously very close to Metro. So we had to take that into consideration, and there's quite a complex foundation system with helical piles that I'll show you a picture of that later. So this ground floor, again, is a very small apartment lobby. Entry is off of New Hampshire Avenue. We have a small elevator lobby, package room, bike room, utility rooms, and then this 3,000 square foot retail space. We are at about 22,920 gross square feet for the whole building, and it's about 63 feet tall. So you may have realized by now that the site was not particularly conducive to modular construction, given that, you know, the modules are typically rectangular and this site was sort of a triangular situation. But we actually got it to work pretty well. We have 4 apartments per floor. They're all 3-bedroom, 2-bath apartments with generally this sort of center living space, except for this unit down here. And each apartment is comprised of essentially 3 of the modular boxes. I'll show you a diagram of that in a minute. So these apartments are very flexible, could be roommate situation, could be a family situation. One interesting thing about the modules comprising one apartment is that, you know, each box has its own wall thickness. And so when you have 2 boxes coming together, you end up getting these very thick walls between the living space and the bedroom space. And I think it's, I mean, we haven't seen it in place yet, but I think it will give a really nice sense of solidity to the building, which otherwise, being wood construction can tend to feel a little bit lightweight and hollow sometimes. So I think that this will give a nice deeper jam and a sense of more privacy between those spaces, since these units aren't very large. So I think that'll be interesting to see in reality. And then this is the penthouse floor of the building. This is all stick built in the field, no modules up here. We have one singular unit on the roof, again, 3-bedroom, 2-bath. We have this sort of community lounge that you enter right into when you arrive from the elevator, and then a large outdoor terrace, and then green roof on the rest of the building. So this diagram shows how the modules actually make sense of the building. So this again was that first unit, and the 3 modules stacked side by side. Everything in white on this sheet shows all of the stick-built production that will happen in the field. Some of these boxes, you'll notice, you know, the module is rectangular, but the space is kind of chamfered and cut off in that area. And the reason that it's drawn this way in the diagram is that they are fabricated as these big rectangular boxes, and they have to be in that shape in order to ship them easily. So they will modify the box in the field and cut off the corners that are no longer necessary. In the section, here you can see the retail area. One thing I wanted to mention was that we were required by the zoning to provide 14-foot clear retail space along this Georgia Avenue corridor. So we have that, and that actually, I think, helps to give the building sort of a taller, more slender appearance. So then the steel construction is this bottom piece, and the wood modules stack up on top of that. We have 18 feet up to the first floor of the first module. And you can see again, like the sidewalls, we also have sort of a double structure at the ceiling of the module to the floor of the next module. And there's some blocking in there, and there's about a 5 3/4 inch space in between. And that's where some of the sprinkler system and exhausts for kitchen, bath, and laundry can go through those zones to exit the building. It does give you a thicker floor sandwich, and we do have a taller floor to floor in order to get a 9-foot ceiling in the units. So that is, you know, maybe one of the drawbacks of the modular construction is this sort of double structure everywhere. And sometimes it's a benefit, and sometimes it's, you know, not ideal. Here's a larger diagram of one of the units. And what I wanted to show here is, like Jennifer's project, these modules will come almost completely fitted out. They will have all of the interior finishes, millwork, cabinetry, plumbing fixtures and fittings, all of the appliances. And these were some of the sort of feature areas in these apartments. We have this kind of entry shoe cubby and coat hook area right here. And this isn't an image of the kitchen in this particular unit, but this is what we saw when we visited the factory. And then we had this sort of millwork closet cabinetry in the bedrooms. And part of that was to save a little bit of wall space, essentially. So we get this nice built-in look around the bed. So here are some images in the factory. Essentially, it is an assembly line. So everything starts on the ground like this, on these big carts, and it's effective because people don't have to be on ladders. So it's much easier to actually do the construction and make this construction more perfect and precise, and to manage the quality of it. This factory is not robotic at all. It's all hand on the wood process. So it's interesting to see that. And again, here's an image of somebody working on the roof of one of the modules, and the factory is full of platforms and stairs and gives everybody very easy access. So they can get clean cuts and clean drill holes for all of the wiring and all of the rough-ins. And that is definitely a benefit. And then the modules are put on these large carts, and they are moved from one station to another as the rough-ins happen and all of the different elements of the box get put together. So here's our site. This was probably 6 weeks or so, probably more than that ago. And you can see here, these are the helical piles, and these are essentially just really long pipes that go into the ground about 30 or 40 feet. And then they have these concrete pile caps that sit on top of them, and then the concrete slab sits on top of that, and then the steel sits on top of that, and then the boxes finally sit on top of that. And all of this was in order to minimize the stress on the land around the metro. And then here we are. This is about a week ago. So we've got our slab in, and our modular, our plinth, our podium is almost completely constructed. They've installed the entire pan deck. We're waiting for the concrete to be poured later this week, hopefully. And then the boxes will be set on top of that. They'll be held together with, they call it an ATS system, and that will allow the boxes to be locked into place and then locked into place all the way up through the building. And then I was hoping that we would have an image of the crane actually swinging one of the units into place, but as construction will have it, our timeline got a little bit delayed. But here's an image of one of the modules in the factory getting ready to be wrapped and shipped. Our factory, luckily, was closer than Poland, and so the logistics are not quite as involved. Our factory is in Scranton, Pennsylvania, and so all of these get loaded onto a truck and driven to DC. Currently, we have a big staging area on the old Soldiers Home site, and I think we have about 20 modules sitting there right now waiting to be brought over to our site and then picked up and dropped onto the podium. And then hopefully sometime at the beginning of next year, we'll have a building that looks something like this. Thank you.
All right. Thanks, Megan. One quick question. Jennifer mentioned that their project was projecting a 5-month time savings as opposed to field built. Do you have any estimate when you guys started your project of how fast it would have been compared to normal construction?
I think that with this project, there's been a big learning curve. I think it took us a lot longer to prepare the documents to understand how it all fits together. I think if we did another one, that there would definitely be some savings, because obviously we would have more experience and know how to prepare for it better. We probably would choose a rectangular site, and that would be helpful. It took us a long time to get the plans to work.
Yeah, I think there was about a year or so of kind of ramp up and learning curve in order to kind of understand, what we were getting into. And, it's important that we took that time to kind of ask questions, figure things out. But to Megan's point, I think it probably added duration to this particular project. I think if you were doing it again, you probably could do this project in 12-ish months, wood frame. So you could probably do it in maybe 9, 10. I think you're probably only really saving maybe 2 months.
Yeah.
But that's just a swag in my experience.
The one thing that I didn't mention is they'll be able to set about 6 of these modules per day, and we have 44 modules, so it'll only take about 8 days for them to set all of the apartments on the project, and then the rest of it will be stick built in the field. So So that will definitely save some time.
Yeah, allegedly.
Allegedly. Yeah, we'll see.
We were hoping, as Megan pointed out, we were hoping to have some photos and having them swing some units yesterday, but it's been pushed a week. And so we can certainly follow up and let you know how that goes, Eric.
Okay, cool. Thank you. So we'll get to some other questions after the last presentation. So I'll ask you to unshare, and now we turn the screen over to Jean Frogel. So we first started with hotels, and then we went to multifamily, and now we have a company that's pushing the boundaries on prefabricating structural components of single-family houses. And not a lot of us know, but a larger and larger percentage of our houses are being built inside factories. And Gene and his company certainly have been at the forefront of that in this area. So I turn the screen over to Gene. You're on mute, Gene. You're still muted.
Hello, can you all hear me?
I can hear you. We can hear you.
How about the screen? Can you see my screen?
Not yet.
Okay. It's right there.
I'm trying. Where is the fucking ring?
It's right there.
I'm here.
Okay, can you see my screen now?
Not yet.
I need to get over there.
All right, bear with us.
No problem. We've all been through it.
Where is it? I'm trying. Why can I not do this? It's right here. Share.
Can you
There you go.
see it now?
Yes, we see it now.
Okay. All right. Well, I'm really impressed with the other presentations, particularly in their boldness of innovation, which is what I really believe. So Annandale Millwork and Allied Systems, we're manufacturers, and we build roof trusses, wall panels, floor trusses, and we call them structural building components. So in the corner of my presentation, you see the SBCAS, Structural Building Components Association. That's our group that you know, represents us and you know, is our organization. So my title is the original offsite solution, because that's a buzzword now, offsite construction. And we've been at it here now for a good 40 years. So we feel like it's something that we know about. Now, innovation, you know, I'm going to combine two of my heroes here into a philosophy I have. And, you know, Vince Lombardi was the legendary coach. Great biography of him by David Marinus. I recommend everybody to, it's worth reading. But he's famous for saying, winning isn't everything, it's the only thing. And I know that sometimes that's a turnoff, but I think when you understand the man, it's more about the perfectibility of your craft. And so in what I do, we're always looking for, how can we do it better? How can we do it more efficiently? So I combine that with another famous person, Joseph Schumpeter, famous economist. He's often credited with the idea of creative destruction, which is this notion that innovation changes the paradigm of building, or any industry for that example, and that it's necessary for the growth and eventually improvement of whatever it is you're doing. And so I combine the two ideas, and I think innovation isn't everything. It really is the only thing in business. And by that, I mean, we're always looking and striving for ways to improve what we do to become more efficient. I think sometimes of Kodak, which, as growing up, that was the only, you know, photography company that passed by the patents on digital photography. So if you're not awake, sometimes the whole industry can pass you by. So structural building components, roof trusses, floor panels, floor trusses and wall panels you see right there. And that's a house that we built. This is a roof truss here being swung into the large 70,000 square foot church right in Vienna, Virginia. We supply the roof trusses. You can see it's a little complex there. We built these trusses in our factory in one shift. and delivered them the next day. And this particular roof truss was erected in 1 day. And if you had to do it by hand, I think they'd still be doing it. So it's a remarkable improvement in speed. Wall panels, this is a picture of another job of ours. Winchester Homes is a large client. This is White Oaks right there in Fair Oaks. This is a 5-unit townhouse. All those walls that you see there, we built in our factory. So I'm going to give you a little bit of the history of here, the Thomas Edison. So the metal steel plate connector was invented in 1952. You see that little thing on the right? Doesn't look really that interesting, but it's a steel plate that's punched and nails are on the other side. And sometimes these innovations take two people. So this guy, J. Calvin Juret, kind of patented this gang nail, and it became Mytech Industries, which is one of the largest steel plate and software companies in our industry. It's now owned by Berkshire Hathaway, and they are off and running. So this little innovation in the 1950s spawned an industry that really is about a $6.1 billion industry. We have 1,800 factories all across the country and over 80,000 employees. That's at the link to the website if you're interested. So we contrast this to what was done before 1950 and kind of what happened in the 50s and 60s. We refer to it as stick building, and you can see the horror there. And this goes on in lots of parts of the country still, where you deliver a big stack of lumber out onto the job site, and then of course the carpenters come and they pull the blueprints out, and then they start erecting the house. Very time consuming, and but it's still really prevalent in the United States. Our larger clients, Pulte Homes, Richmond American, K. Hovnanian, they almost have all kind of gone on to what we're doing. So I want to introduce you to this concept of framing the American dream, the best way to frame. In our website there, you can go to that, and there are a couple of videos. They did a time and motion study in 1996, and then we repeated it in 12-15. We built 2 identical houses and had one stick framed and one componentized, and it was extraordinary. This is real data that we collected, and it really shows and really proves how components save time and money. So absolutely fewer jobs to erect. Builders can build more houses. And I have a dumpster showing there, decreased job site waste. Other people have talked about it in the presentations, but you know, typically that's about a $600 expense each time. And in the process of building a home in our region, sometimes it could represent 4, 5, 6, 7 times. So the more you can save on that, then the more you're saving in dollars. And then we're more efficient with the way we use lumber. In our factory, we almost never throw anything away. I mean, the smallest piece is maybe 6 inches, but it's all reconsumed into the building of panels or trusses or floors. So the crucial takeaway, look at that. 376 hours to stick bone. This is a typical 2,700 square foot home versus 152. Wow, that's just a no-brainer. And then the other important benefits, the saving, you see the little dumpster there, less waste, more efficient use of resources, and you build more. And then for investors, less carry time. We can frame a big single family up in a week, and probably if you're looking conventionally, it's about 3 weeks. All right, so what other important part did this metal plate invention create? Well, it's the software that goes with it and the ability to design really unique roof truss designs and houses. We call it mass customization. And then the engineering accuracy. I'm always struck about when I see these places where hurricanes have come through. You know, we do a much better job in designing the houses structurally sound and to allow for the wind loads and the seismic loads. That doesn't mean that, you know, a hurricane's not going to cause damage, but you know, one of our houses built in our factory, the way these softwares work are really extraordinarily resistant. We fabricate in controlled conditions. We're able to have longer spans, and that really gives us all kinds of different design capabilities and really beautiful homes. So what's next for our industry? Well, we're experimenting right now with floor panels. You see that. I've done a prototype house where I sprayed the foam in my factory. We think that's coming along. And we're also starting to install windows into the panels themselves. So, and I saw that in some of the modular stuff too. Maybe they're a little bit ahead of us. But I also want to emphasize that the BIM model, building information modeling, is going to be more and more important. The general contractors, Jennifer and Megan, you guys are already doing it, and you guys are looking at how the mechanicals interact in the houses and intersect with the structural components. I have to confess that the residential building community is way behind in that area and quite resistant. We still have mechanical guys that come to the job site and then they just start really cutting away and sometimes cutting into structural members. So it's a big problem in our community, and but I think BIM is going to be one of the answers. So I wanted to end my presentation with a remarkable project that one of our members did in Boston. It's called the Clippership Wharf, and it was a 284 unit apartment. So this is a wood frame job, and just remarkable. And then if there are any questions, I'm available to, can we show the video? We're gonna try to have the video. It's not that long, but it's definitely worth seeing.
Clippership Wharf is a recently completed mixed-use luxury development overlooking the Boston Harbor and the Boston skyline.
Can you hear it?
The project encompasses 4 buildings with 478 residences and approximately 30,000 square feet of retail and community space, all within minutes of downtown Boston. Australia's largest real estate developer, Lendlease, is responsible for bringing Clippership Wharf to life. With projects in several countries, Lendlease understands how to efficiently construct large-scale wood-based structures like Clippership. It relies heavily on leveraging factory-built structural building component systems that include floor trusses, wall panels, and roof trusses. For Clippership Wharf, Lendlease required all subcontractors, suppliers, and MEP trades to utilize building information modeling to identify and correct any potential system clashes before anything was constructed on the job site. Leveraging BIM and component systems dramatically increased the efficient installation of the framing. It also increased confidence among all of the trades that they could install their systems on schedule and avoid systems conflicts on the job site. BIM created a collaborative environment during 3D digital model review sessions that included 2 component manufacturers supplying different products. One CM in Maryland provided roof trusses, floor trusses, component headers, and shear wall subcomponents, while another CM in Quebec provided all of the wall panels. BIM provided a third-party virtual design space that allowed CMs on different software platforms located in different countries to collaborate collectively with MEP trades for a seamless construction experience that resulted in 0 repairs or 0 callbacks related to MEP conflicts. Clippership Wharf is a great example of a large-scale project utilizing the most efficient framing solution, wood-based component systems, built off-site in factory-controlled environments. These component systems minimized material waste, integrated relevant MEP trades, created efficiencies in manufacturing and installation labor, and increased factors of safety for all involved. Clippership Wharf is just one of the many projects throughout North America where wood-based component systems effectively solve the structural framing challenges facing the construction industry today. To learn more about structural building component systems, go to bestwaytoframe.com.
Okay, well, we're headed in that direction.
All right. Thank you, Gene. Let me just share my screen and then we'll take questions. One question for you, Gene, before we move on to the other ones. what percentage of a typical single-family home now built by one of your customers is actually built in the factory, and how do you think you can push that percentage higher?
So in our region, because we're so heavily a residential single family, I want to say it's close to 80%. So now that's, of course, roof trusses, wall panels, and floor trusses. So we have great penetration in our area.
Okay, great. So let me get to the other questions now that other people have been posting. And if there's other questions from the audience, please feel free to post them on the Q&A section. So question for Jennifer. How are the permits handled during the signing and sealing of fabricators' drawings? Our own experience with modular involves the fabricator's documents to be signed and sealed, or did the architect sign and seal the fabricator drawings?
So for the purposes of code approvals, the engineer architect of record was Gensler with their consultant team. We did require signing and sealing of drawings by Polcom, but those weren't for code review. Those were more in a delegated design responsibility.
Okay. And a follow-up question on design for you. What types of provisions are incorporated into the design and construction of volumetric units to allow for future upgrades and replacement of MEP systems, mechanical systems?
So from an accessibility standpoint, all of the equipment can be gotten either through the penthouse or, so we have a chilled beam system, which is pretty unusual in the US, but something that this client uses for all of their rooms. And there are access panels that allow for access to each of the units that either need to be serviced or might later need to be replaced. I don't know about any upgrades. We probably haven't addressed that in the design at all.
And probably a question for Megan and David. What are the funding or cash flow considerations that are unique to building with modular, and how is the risk of fabricator default mitigated?
So in terms of funding, I mean, obviously it's not a traditional construction type that most local lenders are familiar with or comfortable with. But I think at the end of the day, there are enough projects out there to get a lender comfortable with it, as long as you can show that your team can execute and that you've assembled the right team, you know, architect, GC, and developer. And, you know, that's how we were able to, you know, work in concert with Eagle Bank to get them comfortable with, you know, executing this project. In terms of, you know, default protection on the fabricator, you know, we're using a highly reputable firm, BBC, out of North Carolina, and you know, you could theoretically bond the project. Obviously, that adds anywhere between 1.5% to 2% to the project, so we weren't interested in doing that here. But there are these manufacturing companies. I'm not sure about Jennifer's in Poland, but these are fairly large, reputable firms that have done projects throughout the country. It's just a matter of getting people comfortable with their design and their construction here in our local market.
And maybe Megan, can you comment on anything different with the design process to support modular manufacturing?
Well, one thing that I didn't mention was that we did work with a firm called Lab House, and they are an architect who does all modular construction. So they consulted with us and sort of guided us through the things that we needed to know about designing a modular project. So that was really helpful.
Question for Jennifer on warranties, given the long logistical tail. What type of warranties accompany modular construction? Do you get different warranties from manufacturers and installers? Do these groups want waivers once subsequent trades alter their work? So maybe we'll start with that, and there's a second part to the question.
Yeah, I was like, that's a long one. So the warranty as it relates to the Polcom fabrication, they have a traditional 1-year warranty that starts at substantial completion. So in that regard, it isn't different, but we did have to give thought to who else might be touching aspects of work within the modulars. So everyone has their own warrantable language as it relates to a 1-year guarantee from substantial completion. To address, I had talked more about like the damage and the handoffs and all these different inspections. And part of that is to make sure that when we get to the end of the project, that everyone's warranties are intact and their amount of coverage is covered for the project.
Okay, and a follow up to that, second part of that question. Once you've had a chance to inspect the work at a particular stage, are you stopped from claiming a defect or damage by a party that performed the work at an earlier stage?
I feel like you were listening in on my contract negotiations, Stuart. This was a big topic of conversation because there was this expectation that perhaps as things were being fabricated and we're inspecting it, then that should essentially be the, if anything's found after that fact, then there wouldn't be a responsible for a defect. And in fact, like we felt like that was ever more important, that we're performing our due diligence at the job site, but regardless of how the material is being fabricated, that company still has the responsibility to make sure that they're fabricating it, installing it in accordance with the documents, in accordance with their requirements. So in our contract, we were very clear that all the inspections we do don't alleviate that company from any potential defects that might be discovered later after installation.
Okay, Jean, question for you on the factory assembly line. What part is automation and robotics playing in your industry? There's been some articles in the press recently about well-funded startups introducing robotics into the prefabrication process.
Yes, you're probably talking about Katera. They made a big splash. Is that who you're talking about, Eric?
Katera, Blueprint.
Yeah. Blueprint's in Baltimore too. So in our industry, and I talked about innovation, there are some big European countries that are coming. Trustmatic is one of them that I'm thinking of that come to mind. And these are fully automated truss assembly where you basically install machinery and there's 1 or 2 guys. Randak in Sweden is also a good friend of mine down in Florida, has a full Randak line down there. They're very, very expensive though. And the initial investments are upwards in the millions of dollars. But the time savings, they're really proving out. We're not at that point right now because, in our market, the standard production techniques, some of the machinery and equipment that you saw in the video, the one that Megan had, we have a little bit more sophisticated line than that, and we're a little bit more automated, but I think by piece, we get there. We have a great show every year in October, which we couldn't have this year, BCMC. And it's sort of a technology transfer, hub where all the manufacturers of the world come, and there's some just fascinating stuff being done in that area. So it's a long answer to we're getting there.
Probably to both Megan and Jennifer, now that you're in the middle of your modular project, and it may be too early, but is there something that you now realize you could have done differently on either modular projects that would make it, more efficient, or sort of lessons learned even at this early stage of construction?
Oh boy, that's always a tough question. I don't know that we're far enough into the future to have that hindsight yet.
Right.
But I'm sure there will be things that we wished we had done differently.
Yeah, maybe maybe a future webinar. Jennifer?
Yeah.
I'm actually keeping a journal because I feel like every day there's another aha moment of like, oh, I really wish I had known about that 6 months ago. So my attempt is to try to document the journey as we're going. I think for me, the biggest was I did not provide enough staff to manage the submittal and design process. So typically during pre-construction and during early shop drawings, a couple engineers would be more than appropriate. But it's interesting. This almost refers to the cash load question that was asked earlier. The work is so front end loaded. So instead of me having this orderly pace of first we're doing structural drawings, then we're doing MEP submittals, then we're doing finished submittals, we're doing all of that at once. And so it's really hard to digest the amount of workload that's happening up front. So definitely a lesson learned for me would be more staffing up front to make sure that we had the appropriate bandwidth to handle everything that was happening at once.
Maybe a related question to that, Jennifer, from one of our attendees. Why was the decision made to fabricate overseas? What was the thinking behind that?
So some of it was cost driven. It was more expensive to use the U.S. fabricator than to use Poland and China. And then a lot of it was the comfort level of the client because they had worked with both of these overseas fabricators. They have projects in process on the West Coast with both of them. And so they're a lot more familiar with their technical requirements and design standards.
Okay. And I think this one is for Megan, since based on your housing background, does this modular construction technique have applications and implications for affordable housing development?
I think it definitely does. There's precedent for that all over Europe, and I do believe there are some projects here that have gone modular. I mean, again, once you've done the process, I think that it could be very efficient, and especially if you're using a rectangular, more regular site and a very repetitive module, I think it's definitely a great option for the future of affordable housing. Absolutely.
And a follow-up question for you regarding the double floor ceiling assembly. How is this soundproofed, fireproofed, and conditioned? And is fire suppression required in that space?
So it's very typical wood construction. So there's insulation in that space, and you're protected by the drywall. And the flooring of the units is a 1 1/8 inch fire rated APA approved plywood. So you have your protection there. If that interstitial space gets larger than 5 3/4, you do have to condition and sprinkler the space. But we kept it to the minimal so that we didn't have to provide fire protection within the space itself. So otherwise, it's just sort of a typical wood construction, protected with sealant and fire blocking and drywall.
Okay. Question for Jennifer. Based on your presentation, the steel boxes and the transportation and storage costs, and one of our audience members seems to think that adds up to some pretty big expenses. Was there decision making based on what factor the 5 months of time savings outweigh the additional construction costs?
So early on in the process, we ran dual estimates to compare traditional construction to the modular construction we were evaluating. Throughout that evaluatory process, we were running within $500,000 between the two versions. So at the end of the day, we don't believe that the modular construction is more expensive. It's certainly more technically challenging and has a lot of logistics involved, but we're not paying a premium to gain that 5 months on schedule.
Okay. And for Jean, just a comment on the sustainability and savings on waste. You had mentioned a $600 expense for transporting waste to the landfill. Your savings are probably considerably more because you pay to purchase the materials and have them delivered, and then you pay again to have them hauled up to the dump. I guess the point is that doing things in the factory really does have large environmental and sustainability benefits, not just to the expense of the house, but just generally good environmental practice.
Yeah, that's a great point.
And finally, maybe Jennifer, are there any different forms of contract for architects and consultants to define their scopes and services when working on modular projects as compared to, standard projects?
I'm not aware of the agreement being different. Our project was handled directly with the owner since it's a CM at risk responsibility. The contract between us and the fabricator is very unique, but the rest of the process seems pretty straightforward, at least in terms of contractual language.
Okay, and maybe as a final point from you guys, if you guys can just finish with a couple of sentences on what you think the future of modular and prefabrication is for our area. Where do you think it's going to be based on your experience so far? Where do you think it's going to be, 6, 12 months from now, or maybe even 5 years from now? That, will it be more widely used? And then why do you think that? Start with Jennifer.
Sure. So I think prefabrication modular, more the panelized modular, is going to be more prevalent in the DC market. We're starting to look at a lot more projects where we're panelizing the exterior skin. I still think volumetric is going to be very specific, limited applications, both because of the size of the modules as well as the complexity that's involved in it. It's just not as adaptable to all the different types of construction that we have in the DC area.
Megan and Dave?
I can go ahead. I also agree with Jennifer about the panelized construction. We are planning a few projects with Blueprint Robotic out of Baltimore right now. And I think the panelized construction I think it's much easier to deal with and will definitely be the future of at least urban projects like this. But I hope that the modular manufacturing process develops a little bit more. I mean, I'm coming from the experience of this factory that is very hands-on, and I think that's great. But I do think that the more robotic factories tend to have a more precise process. So I think that once all of that evolves, the process, and we are all kind of rising with the education of it, I definitely see a future in it. Now, my project's not done yet, so I might have a different opinion next year.
Dave, any thoughts?
Sure. I think modular construction is prevalent overseas, and I think it's something that, like anything here in the States, we just need to get comfortable with. And I think, with Jennifer's project and our project, you've got a mixed use and a hotel hospitality, and then a mixed use residential retail project. And I think as these projects, evolve and take place and are completed, more and more people are going to get comfortable with what it looks like and the process. And I think certainly there are a lot of pros and cons. We've talked about some of them. I think there are some TBD that I'm looking forward to unearthing, so I get more comfortable on our next modular project. But I think this is the quality of the construction is far superior to what I've seen executed on the site. When you have guys that are working on things in a factory in a controlled environment, they're hanging windows at the same level. They're not 5 stories, 6 stories, 7 stories up installing windows. So you just get a much better construction quality. And so, I think as people get more comfortable, they'll see more projects completed, and there'll probably be more modular construction in our region.
So, and finally, Gene, looks like prefab commercial components are probably the way of the future. Gene, would you like to say something for your prognosis?
You have to unmute. So I participated in a study that was conducted by Home Innovation Research Labs, which is part of the National Association of Home Builders. It was the Builder Outlook on the Use of Components in Offsite Housing. So the result of the study was basically that the builders are open to these new technologies, and I think they are because of the shortage of skilled labor. But there still is out there a negative perception of the word prefab with homeowners. So what I'll say to that is we have to do a better job of reaching out to the homeowners. I think the practitioners here on the panel understand the quality that we're putting out, but that message, that marketing has not reached the end user yet, the homeowner. So I think we have a job to do there.
Okay, great. And certainly George Mason as an educational institution looks forward to being part of that. And it's certainly one of the reasons why we decided to have this panel. I'd like to say thanks to our panel today, Jennifer Max, Megan Mitchell, Dave Jampolsky, and Jean Frogale. Thank you very much for sharing your time, your experiences, and your expertise with us. Before we go, just a couple of announcements. We're now accepting applications for our spring 2021 class for our Master's in Real Estate Development. If any of you are interested, just go to realestate.gmu.edu. We have 2 upcoming webinars this month. On September 17th, if you'd like to learn more about the basics of commercial building and construction, and on September 24th, the basics of environmental and soils report. If you want to attend, please send me an email and I will send you the link. So thank you very much for joining us today. That's all the time we have. Again, thank you very much for our panel. Everybody will be getting a link to the recording of this presentation. Thank you very much for joining George Mason, and we look forward to seeing you at our next real estate education event. Thank you.
Thanks, everybody.